On a property of this age, it's important to understand the consequences of applying a waterproof covering onto a solid brick wall construction property. It would appear that this surface covering is Terralin, which contains silicon and is therefore non-breathable. This building with a solid wall construction is subject to air migration. The air passing through the brickwork has a quantity of moisture in a vapor state. If it hits a cold surface, that vapor turns to a liquid and becomes moisture trapped between the surfaces of the waterproof covering, the render and the brickwork. Under normal circumstances, it would be able to evaporate by a natural effect, but because it's trapped under a non-breathable surface, it remains trapped, and therefore the effects of water expanding, contracting and growing in quantity gives you the effect of blistering and forcing the non-breathable surface covering to delaminate and breach. As you can see, the area of concern that we were asked to investigate has come significantly delaminated from the render, both above and below the split. And you can see where it's sagging and sagging quite a bit below where water has got into it, and the pressure of the water and warming from the sun has caused it to sag. Pinpointing the areas of concern were the main area that we were asked to investigate, but you can also see that there are some lower blistering areas as well. Above it, just below the coping stones on the gable end wall, is also blistering. There was some blistering below the window, which has had a plywood covering. The bottom of the plywood covering is also rotten. There was blistering to the top left hand just below the chimney stack, blistering to the left side to the end of the guttering, which would indicate initially that there was a problem with the guttering. We did go up and investigate, and the guttering appeared to be clean, clear and free running. We can see down the vertical side of the left hand side of the gable end wall there's some movement below the Terralin covering, which is concerning and worth investigation. Below the Mill Street sign, there's some more blistering, which shows delamination. To the bottom left, you can see delamination and a crack of the surface. We also had some slight concerns about the discoloration between the two levels, the upper and the lower level. Normally, this is caused when a waterproof coating is put on by a damp-proof course company. Moisture trying to escape finds it the difference or the joint and then eases out of the joint, causing a slight discoloring. This may or may not be the problem. Until the surface covering is removed, we won't know. And then below that, you can see there's an area that has actually blistered and has broken off, exposing the render below. A close-up of the blistered and broken area of the surface covering shows you how much it has delaminated and the condition of the render below. Close up from the side, this indicates the state of delamination. To the right hand side, you can see there's a clear air gap between the render and the Terralin surface coating. Tap testing allows us to identify areas of the surface covering that have become delaminated from the render below. It makes a hollow sound if you tap it. That enables us to break through, get a scraper underneath it, and as you can see, with very little pressure, the surface coating just falls away. So it's adhered to itself and bonded to itself, but not bonded to the render below. The blistering to the top left area, just below the chimney stack, you can see that it's cracked. When that was removed, there was actually moisture behind there, so it was being contained. But obviously there's a problem because it's delaminated, blistered, and then cracked. We went up and investigated and removed the blistered area, and you can see that the render is actually quite wet. Once the Terraline coating was removed, it will naturally dry out, but the rest of the wall may have the same problem. To the top right hand corner, you can see blistering and more cracking to the Terraline. The left hand photograph identifies the extent of the delamination that when peeling off, the Terraline is coming off in quite large pieces. So the Terraline itself is holding together, but it's just not adhered to the render below. If we look at the right hand photograph showing the extent of the delamination to the bottom left area identified by the arrow, it shows you it's clearly delaminated from the render below and can simply be peeled off. To the right hand side of that photograph, you can see the condition of the render below. That is indeed cement render, which has become quite sandy and lost its ability to adhere. This will obviously need addressing. Once the Terraline surface covering had been removed, we were able to identify a number of cracks and issues within the render below itself, starting with the crack from right to left at gutter level, not running the full width of the building, but certainly 75%. We then had another crack mid-range. The main concern is the vertical crack running from the coping stone down to the ground floor. This may indicate that the frontage of the building is suffering some movement, and you may find that the brickwork is cracked below the render itself, but we would need to remove the render to identify this. We then had another crack running vertically on the left lower side of the gable end. We had a small vein crack running from the main front crack to an area within the render that has already fallen away, and the render itself has become separated from the brickwork below as identified by the circle. On the left hand side, there's an oval area which indicates that the render there has also broken away from the brickwork. Although it's holding itself in place, it's not thought to be attached to the brickwork below. The circled area blown up on the right hand photograph identifies the extent of the render breaking away from the brickwork, and this will obviously allow moisture to get inside. Once again, a good winter could possibly cause this to blow completely and separate from the building itself. A close-up shows the extent of that broken away render. We were able to get fingers behind and apply a small amount of pressure, but the render seemed fairly well adhered to the brickwork below, or is wedged in place, and certainly didn't feel loose, and it is unlikely in the short term to fall, but it should be investigated further, and this issue should be addressed. Testing. We took a sample of the render from the gable end wall and applied an acid to look for a chemical reaction. We didn't receive a chemical reaction, and therefore we can assume that the render has 0% lime, making it probable to be Portland cement render, which is non-breathable and shouldn't be applied to a solid wall construction or constructed building. The brickwork was tested for moisture content. We drilled through the render and took a sample of the brickwork below. Using a calcium carbide pressure vessel, we measured the true moisture content of the building sample. Top left gave us 4.9%, top right 6.9%, middle centre 1.9%, and the bottom left gave us 1%. With an acceptable building tolerance of 7% in building material, we can assume that the brickwork, as it stands today, is currently in a reasonably dry state. The property was constructed during or pre-1900s and is Grade 2 listed. The 1971 listing protects 37 and 38 Greengate Street. The listing reference is below. I'd like to bring to your attention that although the decision to list a building may be made on the basis of the architectural or historic interest of one small part of the building, the listing protection nevertheless applies to the whole building. This was taken from the Historic England website and should be adhered to, as it is a criminal offence to conduct works on a listed building without consent. The construction consists of a soft clay handmade or low temperature fired clay brick, bonded with lime mortar to form the solid wall construction. This form of construction requires the materials to breathe and allow moisture molecules to evaporate through the natural drying process. The application of modern materials has been applied to the gable end of the property, which now prevents the evaporation of moisture after it is condensed from a vapour to a liquid caused by a dew point condition. Modern materials applied on this property appear to be Portland cement render and a Terralin spray-on or trowel and texture roll decorative surface covering. Terralin contains silicon, which makes it waterproof and non-breathable. Water vapour has been allowed to penetrate the Terralin and condense on the surface of the Portland cement render. Once the vapour has turned to a liquid, it is unable to escape and the delamination of the Terralin from the render begins. The atmospheric conditions within the building will contribute to the vapour migration and subsequent moisture buildup. As the trapped moisture expands from expansion caused by heat or frozen molecule expansion, the surface covering delamination is accelerated. To rectify the problem, the Terralin and Portland cement render should be removed. The brickwork needs to be repointed in a hot lime mortar mix. The gable end should be either lime rendered and lime wash applied or left with the traditional brick finish depending on the condition of the underlying brick. The air brick should be cleared and the suspended floor checked for adequate ventilation and lack of joist rot. Once the render has been removed, the cracks should be investigated further and possible helibar crack strengthening might be required. All work should be authorised by the Conservation Department before proceeding, as this is a listed building. Build Fix Property Services, members of the Federation of Master Builders. For all your building and construction requirements, we specialise in pre-1950 property construction, including heritage and conservation, traditional building methods with hot lime renders and mortar, identifying the true causes of damp with testing supported by data analysis, providing environmental monitoring to identify the true causes of damp in pre-1950s and post-1950s properties.